Video, today we are going to study about read versus write patterns. So yeah, we have been studying about this since last many videos. Read heavy versus write heavy. Read heavy. Let's see what read heavy generally read heavy system what fundamentally means. So read to write ratio in the read heavy will be obviously or no it should be more than 10. Then we can call it as some read heavy system. So if we take the examples, yeah, you are right. Social media pages, Twitter, Insta, whatever, product catalogs, right? Amazon, you will read more, you will buy nothing. Yeah, you will buy sometimes. Content sites, Netflix, these are all read heavy. So, what are the optimization strategies for them? Yeah, let me write this. Yeah, first thing is caching. What do I mean by caching here? Storing frequently read data in the memory. Like one good example will be Redis and Memcache. So here we will generally try to stop hitting the DB. So whatever most of the 90% of the hit we aim to get from the cache itself, you can see it from the left side image. So that is one thing. So it can serve almost 100 times more reads when compared to that. So now if we see read replicas, this is also one more thing, read replicas. So it copies data to multiple read-only databases and distributes the read load. So here I am saying not just replica, here I am saying read replicas. So scale reads horizontally by adding replicas. So this is one thing. And one more thing is denormalization. So normalization versus denorm. So normalization means you can think of it like you're having too much of data. You will be dividing it into some, let's say if you take some SQL tables, orders and customers. So we have customers table as different on orders table as different, and we have their relationship between them using some foreign key. So this is what we call as normalization, dividing the existing data. Here denormalization means if we include if we try to merge both, what we call it, join both order table and user table. So then that is nothing but denormalization. During that time, you can read faster because see if they are in the separate tables, if you want to read, you need to do the joins and all those things. It needs some processing time and it leads to some latency. So that is the issue. So with denormalization, you can write everything in a single query instead of using multiple joins. And next thing is content delivery network. So whatever static content like HTML pages and all these things are there, we generally try to cache them in the edge locations. Let's say you are in some city like Hyderabad, so you might have a Netflix CDN there, and Netflix videos might have been stored there. I am not sure, but so whoever are there in the Hyderabad and whatever they are watching, let's say during the Stranger Things season, I think most of the people will be watching the Stranger Things. So that videos like in some encrypted way they will be stored there itself, and so you can access them, read them from there. So this diagram you can refer for how a read heavy system should actually look like. And if we see the write heavy systems, so whatever, one second, if read is to write ratio is less than 3 is to 1, then we can call it as write heavy system. So Here you don't confuse it. Here I am saying again read is to write only. Previously also I said read is to write. Here also I am saying read is to write. Even if for every three reads you are getting one right, still that is a write heavy system. You should consider it as write heavy system. So examples if we take as logging, that is a write heavy system. IoT sensor. So these generally for every milliseconds or for every second they try to log data. So messaging. This is also a kind of write heavy system itself. So yeah, messaging. So don't confuse this message with Instagram. So Instagram is not primarily built for messaging, it's for content viewing. So yeah, YouTube, all these things comes under read heavy systems. Here normal WhatsApp, that comes under messaging and that comes under read heavy write heavy system. So if we see here optimization strategies for these things, optimization strategies. First thing is right behind cache or whatever, right ahead cache or right behind cache. So before this we will keep some thumb rule we shall remember. With that we can derive whatever we need. So whenever we try to build a right heavy system, one thing we keep in mind is that we try to accept all the write request and send acknowledgement as fast as possible. It is not necessarily to write that it I mean see we can there is a chance like we send the acknowledgement now and we can write them as it is a write heavy system. We can send the acknowledgement now. So as it is a write heavy system, they won't read it immediately. So at least probability. So the read query doesn't come immediately. So we have some time left there. So during that time we can do some background processing and write that into disk. So between writing the disk to the actual request, we have some time left. So this time we can use and we can send fast acknowledgements and we can do some background processing and increase the decrease the write latency. So this is the main idea. So one of the implementation of that kind of thing is right behind log, right behind cache, sorry. So what we do is like before flush to db, what we do before batch flush to db, we write it in memory. Like we write it in memory, like let's say we try to maintain some table or something like that. We try to write it in the memory only first, because memory writes are faster and we can send good faster acknowledgement. So whenever we write in memory, after that table fills, we can flush all those batches of writes to database at a time. So this is one idea. And one other thing is append only logs. So for this, we a type of thing is something called LSM, log structured metric tree. So what we generally do is like we try to do sequential writes with this. We try to do sequential writes. So here we will be having something called mem table, ss table, and then we will be writing that into disk. So here also we are buying some time by giving faster acknowledgement. So I have been talking about this in the previous video in this playlist. You can watch that if you want more clarity. So here actually sequential writes happen. not random writes. So random input output. And don't confuse random access memory with random access write. Both are different. Random access write takes too much of time, and random access memory takes very less time. So this thing you can Google it. This often people confuse it. Now sharding. Sharding makes writes easier. Distribute writes across multiple database servers. That is very easy. And now if you see asynchronous processing. What is asynchronous processing? Yeah, it is also same. We need to buy some time. We will use some queue. We will keep all our writes in some queue, and we will accept the write. We will queue for processing and return immediately. That's it. So you can take example here left side. So now we shall go through some examples of real life examples. If you see Twitter, what do you think? It is read heavy or write heavy? It is uh, read heavy, obviously. If you see read by write ratio for Twitter, it is 1000:1. Here, and any e-commerce like Amazon, Flipkart, their catalog viewing, it will be around 100:1. These are generally rough calculations to keep in mind. For banking transactions, these are also read heavy. How many times did you check your balance? Even if they are negative, even if they are negative balanced, we'll be always using the UPI to check the balance continuously, right? Even though the money won't increase, how many times we see it. And chat messaging, I have been, people might obviously confuse here, but actually this has some 3:1 ratio, like 3 reads to 1 write. So this one we can consider as write heavy. This is actually the border between write heavy and read heavy. We should consider anything which is less than 3:1 is write heavy. So this one we can say both write, read, both are equal. Like not equal, they are both optimized for both. IoT sensor data, obviously write heavy. So read is to write will be what? 1:100. And if you say logging system, yeah, you are right. 1:1000. You can see here. Actually, this can be 1:10:1 or 1:1. Okay. So balancing reads and writes. What does caching do here? Caching helps reads. Read replicas helps reads. Sharding helps what? Sharding helps read a bit, but it helps write more. Denormalization. What does denormalization do? It helps reads. What does asynchronous writes do? It helps writes. So yeah, now we shall see how we will optimize a read heavy system. Obviously CD and cache, read replicas, all those things. How will we optimize the write heavy system? Yeah, we just now discussed them. Let's say we are having a system which has 90% reads and 10% writes, but still the writes must be strongly consistent. How will we design it? So what here, it should be strongly consistent, not eventually consistent. So what does this mean? So whenever, let's say you are having some balance, so whenever you send some money to other guy, it should reflect in his bank account immediately, not after like 10 minutes, something like that. So that is what strongly consistent means. So we will, instead of writing to read replica, so sorry, one second. Yeah, sorry for the disturbance. So yeah, so what we will do first of all here, the main thing is like strong consistency. Strong consistency means the read should be correct and the write should be obviously correct. So first what we will be doing here is, first whatever writes are there, we try to write it to the primary DB itself, and we will make it synchronize with the read replicas eventually. So they will be trying to sync with the read replicas. So after one write, whatever the read comes immediately after the write, so we call them as post reads. So whatever post reads are there, we try to send them to primary DB itself, not to read replicas, because they it might take some time to synchronize. So synchronize between read replica and the primary DB. So what we do is like post reads are sent to read replica only. We try to do it. Read your writes, whatever we call this is like a read your writes to maintain the consistency, and we will do the cache invalidation very correctly to prevent so whatever happens to writes, because see, if this cache invalidation most cache invalidation is not correct, then all these things will be going wrong. So yeah, that's it for this video. So we shall see in the next video. Thank you.